dear ladies and gentlemen, we are very happy to welcome Professor Indrajit Mukhopadhyay. Dear Indrajit, could you please tell us more about the research that you're doing, about the goal and the mission of your research laboratory?
Well, so the first part of my research goal is to make basically devices, intervene in new materials for energy conversion and energy storage devices. So what I work on at the moment is on two or three parallel projects. In one of the project, we actually do electrodeposition and electrocrystallization of semiconductor nanoclusters in two-dimensional array structure for applications in photoelectrochemistry as well as photoelectrocatalytic water splitting. The other part of the two projects actually run on the development of new materials for high energy density lithium ion battery. We are actually developing silicon-based composite materials which can be used as negative electrode for lithium-ion battery.
Thank you so much for this information. What is the big vision of your laboratory? What do you want to achieve?
So for society, actually, the two targets I have set. One is to come up with indigenous high energy density, battery, basically cylindrical as well as pouch cell in the long run. That is what our first goal. And second goal is to make large area thin film electrocatalyst development for efficient water splitting to generate green fuel hydrogen.
Mm-hmm. That sounds pretty exciting. Tell us more about the structure of your research lab. As I understand, you need to have people who are coming from different disciplines.
Let me tell you. So I'm working actually in the Department of Solar Energy in the university. The university name is Pandit Dindayal Energy University. It was established by the state legislation of Gujarat under the Union Government India. And in the school, we actually offer a master's program in energy systems and engineering. And in the research group, we have a center. It is called Solar Research and Development Center, which I am heading at the moment. And this research center is having all the facilities for synthesis, characterizations, and performance evaluations of thin film as well as 2D assembly of nanoclusters based devices. So we have on the synthesis side, we have complete thin film laboratory, which is actually having facilities like DC and RF sputtering. And then we have spray pyrolyzer. We have several electrodeposition or electrocrystallization units, electroplating units. We have also chemical deposition CVD unit, couple of CVD units we have, and several crystallization or recrystallization thermal furnaces like high temperature furnaces, program furnaces, RTPs and all. So these are on the thin film side. Of course, we have chemical bath deposition and chemical synthesis like hydrothermal, solvothermal for synthesis of nanoclusters or nanopowders are also there. We have on the application side, we have complete button cell, lithium-ion button cell preparation, fabrication unit. Several components are there in the whole line. For performance measurements, we have solar simulator. We have, electroanalytical tools. We have spectrophotometer, UV visible spectrophotometer, photoluminescence measurements setup is there. We have Raman scattering measurement setup is there in the center. Of course, we have field emissions scanning electron microscopes and X-ray diffraction, powder X-ray diffraction pattern acquiring units. So And on the performance measuring side, we have battery performance measuring unit with biologic systems. We have new con systems from China. We have spectrum analyzers from Germany. So several techniques and several performance measuring equipments are there. So in a word, I can tell you that from atom or from ion molecule, we can go up to device level. We can characterize in the thin film format, and we can do the performance evaluation.
Sure, thank you so much for this information. There are a lot of methods which one can apply, and there are a lot of approaches that one can use. How do you decide which kind of projects do you develop in your lab? How do you decide which projects do you want to pursue next, which you give to your scientists, to students, seek collaboration? How these decisions gets done?
Oh, yeah, so I'm a member from Electrochemical Society as well as from the American Chemical Society. I'm a life member basically. So I get all the database, SciFinder I can access. I have access to individual access to the database of Electrochemical Society. Also, from the university level, we have different database accessibility like Elsevier, different journal packages, and then different other centers, as well as we have access to the Clarivate system from Web of Science. So from all these database, actually, we do the literature surveys, keep us with the contemporary research subjects or topics that is going on in the world and coming to be more important in the future. And that's how we actually manage our literature survey as well as setting future direction of our projects.
Sure. So you have different search engines for the literature, right? To search for the information.
Yeah.
That is quite helpful. But how do you define strategically which kind of projects would you like to have? How the idea for the next project occurs? Is this more coming from the government, collaboration with some companies?
It is actually, let me explain you. We have the call from government at different times, and depending on expertise and the avenue of opportunities, we actually go and apply research project accordingly. Of course, the bottom line is that the facility and the infrastructure that we have in our center. So keeping that in mind, we actually respond to different call of the government of the contemporary projects.
Mm-hmm. How big is your research laboratory? What is the structure of the lab? Do you have more students or more postdocs?
Yes. Let me tell you, our this department, we have a department, academic department, it's called Department of Solar Energy, where about 18 students annually can be accommodated, can be given admission for their master's program in energy systems focused on solar energy. Apart from this MTech program, we have around 14 to 18 PhD scholars who works in different projects and different fellowships under the government to carry out the focused research that we set in our center. From the faculty point of view, it is a multidisciplinary research. So we have faculty, I am from chemistry background, physical chemistry background. We have faculty from inorganic chemistry. We have faculty from applied physics. We have faculty from mechanical engineering, as well as we have adjunct faculty from electrical engineering. Mm-hmm. So that's how the whole system works.
Sure. We are mostly focused on the life medical sciences, basic or applied research, and such structure of the research lab is pretty new to hear to me. But this is, of course, interesting to know more about. If we are looking in the meaningfulness of the projects which you conduct and the biggest impact that they can deliver, what projects would you highlight with the biggest impact where you believe can be achieved?
So as I told you that the main focused area are the two, hydrogen generation, green fuel generation, as well as energy storage. So I think the energy storage is going to be a very important area in the coming future. As well as in the thin film, we have some biologic applications also we have studied. Although we are material scientists, so if we found some materials or some nanoassembly is very good in specific biological applications, then we do study that also. In like that, we have a project on estimation of carcinogens in food materials by wet electroanalytical tool. That is also we have that paper has been published in very good journals. So if you want me to choose one out of three, then I will go for the energy storage area, because that is going to be very, very important in the future applications.
Sure. Where do you see your research for this specific project? Where do you want to take it in 5 years from now? How would you ideally develop it?
Well, so we have already, I think if I tell you the TRL, that is technology readiness level of my projects, then I think we are much ahead with the silicon composite based high energy density materials for lithium ion battery. In 5 years, we are hopeful that we will be coming up with some commercial negotiation.
That's very exciting. It's very good to hear.
Yeah.
How do you search also for the collaborations with the companies? Are they reaching out to you, or you reach out to them? How does it work?
So we have a few companies who are working in this field, and they are in constant touch with us. So we do in collaborations with the company. We take projects from them, help them in their analysis also, and that's how the nexus is going on. And as and when I will feel that my product is in a level to be tested in the industrial facility, I will go ahead with them with the proper know-how exchange and all legal matters.
Sure. Our audience can consist of several groups of people, and normally we also mention patients, but in this case this is not relevant. So I will stay with students, those who are scientists or young generation, and they would like to join your laboratory. These are those who are consumers, and these are those who are investors. What message would you have for each of this audience? Those who want to join your lab, collaborate with you, those who are consumers, and those who are investors?
So the only belief that means only strength is the only thing that one should believe, his own capability and own strength, and should pursue the work as per his interest. That is very important to come up with some fruitful results in whole lifetime. And for the students or for the research scholar who wants to join my facility, I can tell them that we do carry out research at the high standard level in complying with the international standard, and which can be seen from our publications and other facts and figures. And if they join, they will get the whole facility. Of course, most of the facility is within in-house, so their research, carrying out research of a particular subject of area of interest, which is available in the department, will be very fast.
And investors, what do you think investors should know about your research?
Well, so the lithium-ion battery work that I'm doing, it is based on cutting up many unit operations to get economically viable and very high energy density material for lithium-ion battery, which at least my country is looking for in the coming future, as well as the whole world is looking for such kind of material based on silicon. So that should be the focus.
Good. Thank you so much for this information. Is there anything else that the broad audience should know about your research? If you would have such a tool where you can shout out to millions and millions of people worldwide at once, what would you say to them?
Okay, so I really want to extend my facility to people through international collaborations or international exchange in a proper legal way through Government of India. And for the national people, most of them, they know my activities, and I have many good students, and I want to have many more, capable and very motivated students to carry out our work, so they can see the opportunity from time to time and can uh, try to join us or reach us. We will be very happy to accommodate.
Good. Thank you so much, Professor Indrajit Mukhopadhyay today. It was a pleasure to have you.
Thank you.